In this lecture, we will discuss the basic procedure for the modified distribution method, that is MODI method, to find a optimal solution of transportation problem. For the solution of the transportation problem, first we have to find the initial basic feasible solution by northwest corner rule method or least cost method or VAM method. Once the initial basic feasible solution has been calculated, then next step in the problem is to determine whether the solution obtained is optimum or not. After find out the initial basic feasible solution, we have to check the obtained initial basic feasible solution is optimum or not by optimality test. Optimality test can be conducted on any initial basic feasible solution of transportation problem, provided such an allocation has exactly m plus n minus 1 non-negative allocations. Here m is the number of rows or number of origins and n is the number of columns or number of destination. And also have to check these allocations must be in independent position. For optimality, we have to check the allocations are exactly m plus n minus 1 or not, and also have to check these allocations are in independent positions or not. To perform this optimality test, we shall discuss the modified distribution method, that is we are calling as the MODI method. Now we will look for the procedure for the MODI method. First step is find the initial basic feasible solution of a transportation problem by using any of the three methods, such as by northwest corner rule method or least cost method or VAM method. Second step is find out a set of numbers ui and vj for each row and column. So here I have to find out the set numbers, that is ui for the each row and vj for the each column, which is satisfying the ui plus vj equal to the cij for each occupied cells. So to start with, we have to first assign a number 0 to any row or column which having the maximum number of allocations. If this maximum number of allocations is more than 1, then we have to choose any one randomly. So third step is for each empty cell, that is for each unoccupied cell, we have to find out the sum of ui and vj written in the bottom left corner of the respected cell. Fourth step is find the net evolution value, that is delta ij equal to cij minus of ui plus vj for each empty cell, that is we have to determine the delta value which is equal to the cij minus ui plus vj for unoccupied cells, which is written at the bottom right corner of the respected cell. So this step gives the optimality conclusion. So first one is if all values of the delta ij greater than the 0, then solution is optimum and a unique solution exists. Second conclusion is if delta ij is greater than or equal to the 0, then solution is optimum but an alternative solution is exist. Third one is if at least one delta ij is less than 0, if the delta value is negative value, then solution is not optimum. In this case, we have to go to the next step to improve the total transportation cost. So if the delta value getting the negative value, then I have to go for the modifying the allocations. That is, I have to see in the fifth step. So fifth step is select the empty cell which having the most negative value of the delta ij. From this cell, we draw a closed path by drawing horizontal and vertical lines with the corner cells occupied. Then we have to assign the sign plus and minus alternatively and find the minimum allocation from the cell having the negative sign. This allocation should be added to the allocation having positive sign and subtracted from the allocation having negative sign. Sixth step is from the above step. So in the fifth step, which yields a better solution by making one occupied cell as empty and one empty cell as occupied. See, in the fifth step, we are modifying the allocations. So for this new set of basic feasible allocations, repeat from step 2 onwards till an optimum basic feasible solution is obtained. So repeat the procedure until the delta ij is greater than the 0. So this is the procedure of the body method. Thank you.